Welcome back, everyone. Now, we're really going to get to the definitions of speed and velocity and all of those. But the easiest way to do that is with a little bit of a case study, okay? That's what we're going to call it. So what we have here is my friend's walk. We saw this before. And now we're going to try and make sense of it, okay? So if we look here, we've got her walk, and they say to us, now, look at what the information is at the bottom of this. Whoops, wrong way. Okay, so over here, they tell me that it took 47.50 minutes. Her average speed is 10 minutes, well, her rate. It's not actually her speed. They say it's 10 minutes, 53 seconds. So they're saying to me that my friend could walk on average a kilometer in 10 minutes and 53 seconds, okay? If I look at this and I go, let's calculate her speed. Speed is a scalar, okay? So speed needs her distance, okay? Now, let's do it on the next slide. So we knew it took 49. Let's just check. Oh, sorry, 47. I was going to make it even slower. 47. Let's just fix that. 47. Oopsie. 47 minutes. Okay, and 50 seconds. Now, the first thing is I can't work with minutes and seconds. I need it to only be minutes, or I need it only to be seconds, okay? So I could work this out in kilometers per minute, or kilometers per minute, per second, and speed needs to be meters per second because it works with distance, and my unit for distance is meters, and my unit for time is seconds. So I need to convert this into minutes, into seconds. So what we've got to remember is there are 60 seconds in 1 minute, okay? So here we go. I've got 47 minutes. So I'm going to take 47 times by 60. So 2,800, oh, it just sounds terrible, 2,820 seconds. So my time is 2,820 plus that 50. So my total time, 2,870 seconds. That just sounds terrible, but it's okay, it's in seconds. Her average speed, now the distance that she traveled was 4,39 kilometers. And again, we can't work in kilometers, we need to work in meters. So I have to convert my kilometers to meters, and I do that by timesing by 1,000, okay, because there's 1,000 meters in a kilometer. So I'm going to go 4.39 times by 1,000, and we get 4,390, okay? So her distance is 4,390 meters. So she went 4,390 meters in 2,870 seconds. I want her speed. So her speed is her distance divided by the time it took. So 4,390 divided by 2,870. Definitely need a calculator for this. So we've got 4,390 divided by 2,870. Has to be a decimal, so 1,53. So her average speed was 1,53 meters per second. So every second, on average, this isn't her speed at every moment, is 1,53 meters per second. That's her speed. I don't care that it went round all sorts of corners and up and down, and all, that doesn't matter. Okay, that's her average speed. The second part of this was, what is her velocity? Now, velocity requires me to use displacement. Okay. Essentially, she stopped and started at the same place. This doesn't bode well, okay? Because if I now go here and go, well, her velocity, which is a v, is going to be her change in displacement over time. Oh dear, she didn't go anywhere. So she went 0 for 2,870 seconds. She didn't do anything. This is why I don't run races, because you run all this stuff, get to the finish line, and according to science, you have no average velocity. You've gone nowhere. However, if I had to go back to this and say, what is her velocity if she ended at the 4-kilometer mark? Here I can give a velocity now, but it's still going to be very small because her velocity is only this little piece here, whatever that distance is, okay? That displacement would give me her velocity, and it would be at a certain direction. So she would be, and north is here on this map, so she would have gone sort of southeast, southwest, but she can have a velocity. So it's possible to have an average speed, but not an average velocity. Speed doesn't rely on direction. It is a scalar. Velocity absolutely relies on direction. And velocity is about the change in position. We have to know where our starting point is. So, speed is the rate. Rate means divide by time, at which an object covers a distance. Remember, distance is a scalar. Uniform speed, which is not what the runner would have had, my walker, okay, means that the body covers, the object, not a person, covers equal distances in equal time intervals. So if I said that my friend who walked, and we said we got a speed of 1,53 meters, if she had to walk 1,53 meters per second every second for the entire motion, she has uniform speed, okay? Uniform speed isn't that difficult to achieve when we're looking at people walking or cars driving. So if we look at cars on the highway, you should go at a uniform speed of, say, 100 kilometers per hour. You can do that, okay? But it means that every hour you do 1 kilometer, okay? That's what that speed means. Average speed means it's the rate, in other words, we divide by time, at which the total distance was covered. So we calculated for my friend's walk, we calculated average speed. Basically, we ignore the times when they went really slow, and we ignore the times that they went really fast. We just look at the total distance, and we look at the total time. Average, sometimes a little bit more useful, okay? In fact, if you plan a road trip to, say, Cape Town, most people will say to you, plan it so that you'll average 60 kilometers per hour. That average means sometimes you're going to go at 120, sometimes you're going to go a little bit slower. It includes the rest stops, but it's an average. So you can plan how long it would take you to do the trip, okay? And that's if you're obeying all the laws and taking regular rests, which are important. When we look at speed, how do we calculate it? We calculate it with distance divided by time. Speed is measured in meters per second. Distance, which can also be a d, is measured in meters, okay? Time is measured in seconds. However, even though meters and seconds are our SI units, sometimes, okay, we will measure them in kilometers and hours because it makes sense to do that if we're looking at a car that's moving. Read the question, okay, as to whether they want it in meters per second or kilometers per hour. If you're not sure, meters per second. Those are the SI units, okay. If we look at average speed, now watch how my equation has changed. Average speed. I need to use total distance, total time. If I'm just calculating a speed generally and they don't tell me if it's average or not, take the distance, divide by the time they give you. If it's average speed, I need to say I'm calculating average speed. It's very, very important, okay? And I need to know that then I have to use the total distance and I have to use the total time. Be careful that you don't leave something out there. Velocity is the rate of change of position. This is the important thing. Change in position. X means horizontally. Rate of change means divide by time. We're looking at change in position, which means we have to have direction. I can't even emphasize that enough. Direction, direction, direction. And your velocity is in the same direction as your change in position. Okay? Of course, then we can have uniform velocity, which means equal changes in position over equal time periods. And here it'll sound the same. So if I say we had an average speed of 5 meters per second, or a uniform speed, I can also have a uniform velocity of 5 meters per second, but I have to tell you the direction. So I have to say I'm going north, or left, or right, okay? But I have to put a direction in it. Then we get average velocity, which means now we take total change in position divided by total time. Do you see they're very similar, speed and velocity? The difference, it's not the time that's the issue. It's whether I'm using distance or change in position. We will often say the displacement of something, that is the change in position. But we don't use the word displacement in our definitions. Definitions, very, 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 very important, okay? So, we look at our equation. Now it looks a little bit different. V is velocity measured in meters per second, same units of speed. Delta x is my change in position. Okay, measured in meters. Delta t is time, measured in seconds. Again, I could describe velocity in kilometers per hour, but we don't want to do that very often, okay? We really want to be using meters per second because that's the SI unit, okay? Then we get average. Now you've got to pay attention. Look at how I've changed my symbol. Average has to have a line on top. If you don't put the line, it doesn't mean average velocity. Again, measured in meters per second. Delta x is the same, delta t is the same, except this is total delta x, and that is total time. Okay? Acceleration is the rate of change of velocity. So now I'm looking at how velocity changes over time. A is acceleration. We're going to do more of this soon, don't worry. Okay. Acceleration is meters per second squared. It's how the velocity changes in time. That is my velocity, so it's how my velocity changes. Okay, so I have to take two velocities and minus them from each other, and this is time. Okay, so when I go here, and I'm going to introduce some new symbols, it's a final velocity minus an initial velocity. Okay, you're going to see that often. But change in means the velocity has to change. Or if the velocity doesn't change, acceleration is 0. Okay, acceleration is a vector, has to have a direction. Direction's fun. Okay, so, oh look, I went and wrote over my stuff. So here we go. I put that there anyway, so VF minus VI. Oopsie, what I mean by that, final velocity, initial velocity. So I need to know two velocities, okay? Sure, lots of definitions, lots of new symbols. We're going to need to do some calculations. But that's all for now. We're going to take a short break, and I will see you in a couple of minutes.